So hello and welcome to yet another video of this SVA Design YouTube channel. I just came back home from some grocery shopping, so I just really wanted to just have a quick tour of everything that I've been doing with the printer thus far and everything that I haven't shown you guys yet on YouTube. I have been very active on Instagram, so if you don't follow me yet on Instagram at SVA Design, if you're interested in the content, yeah, that is just where you can find more of my daily content that I'm posting. But for now, I have a suspension wishbone setup for like one wheel. So as you can see here, there are multiple components that are fitting into each other. So would be the upper, my bad, I'm turning it upside down. This would be the upper wishbone, this is the lower wishbone. These would be like the hinge points for it to be mounted to the frame, and this would be the upright. And in here are actually multiple components. So this whole assembly actually consists already of, let's count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different 3D printed components that are actually already in here. And as you can see, these hinges can move independently from one another, and they can actually also rotate. So this would mean that it could steer, and also it can rotate on its own mass without a lot of friction. So you can also hear that it doesn't really cause a lot of friction. So I actually made up my own ball bearing system to kind of in-house these ball bearings. I haven't seen it used this way on any other car thus far. So usually they use like standard rubber bush mountings, ball bearings and everything, but this is all 3D printed, no rubber, no ball bearings, metals or anything in here. So yeah, I'm very pleased that it actually works and that it is as frictionless as it is. So what I did do with the ball bearings though is that I kind of use a directional layering effect of the 3D printer to make sure that the friction of it kind of works better, if that makes a little bit of sense. I get that it's maybe a little bit unclear the way I describe it, but there are like, let's say there are these cups that are 3D printed for the ball bearing to sit in, and these cups were printed in this direction. So the layers of the 3D print are in for the cup are actually in this direction. So if you would have a ball bearing, they would also be printed in that direction and would sit directly on top of it. Then the layers would kind of be able to sit into one another and kind of create extra friction, because you have these microscopic layers that are touching instead of them flowing over one another. So the ball bearing itself was, instead of it being printed upright, it was actually printed on its side, so that the grooves are vertically instead of horizontally, so that the grooves of the 3D print layering doesn't match with one another, so that in turn that doesn't create a lot of friction. I hope that was as clear as it can be. I don't really know another way to describe it clearly, but that is basically what I've done to ensure that it is as frictionless as it is, and also just put a little bit of Vaseline on it, so to make it the way it is right now. So that has, all of this has been 3D printed. How long did it take for me to 3D print all of these components? In total, I think this was about 3 hours. This was about 3 hours. This was 7 hours, but I did 4 of them at the same time. So that would be like 1.75. And then let's say that this is an hour for all of these components in here, and this is another hour. So that would be 7, 14, like, let's say like 16 hours in 3D print time just for these components. And I also got more. So I've been printing a whole lot. These are like little black roses. I showed you guys already the first rose. This was actually the first arm that I printed, the suspension arm. But I don't know if it is actually clearly visible on screen, but you can actually see that here there is a curvature that is kind of going up, and especially if you compare it to another one that is just the right way print, then you can maybe see a little bit that the white one is way thinner at the top than this one is, and this is because it kind of separated from the printing bed and it kind of let loose. So I've been going through a little bit of trials and tribulations to figure out a good way to not only get the printer to stick properly, but also to make sure that the first layer just has very good adhesion with all the settings and all of that. So I've been using hairspray, I've been using glue sticks, I've been using a whole bunch of different type of solutions to get that first layer to really stick. But ever since I've been through those and I kind of figured out a way for myself to work with it, and the way that I do it is just with hairspray on the heated printer bed, like 2 minutes in advance before the printer starts, and that way, but also put like a little bit of a decent layer on top of that, and that way the printer, the actual head goes into the actual hairspray, and because that sits at 200 degrees, it kind of automatically makes it hard because of the temperature, of course. So then it applies a layer of plastic within the hairspray, and then it is solidly mounted to it. So that really works for me. It is a little bit difficult to then get some of the 3D print components off the print bed, but I rather struggle a little bit to get it off the print bed than to actually have a successful 3D print. So that is why now all of these components are turning out to look like this, at this type of quality and everything. So of course the bottom side is a little bit worse because that is where the support material and everything needed to be printed, but the top section is just really A-class surfaces that are really good. This is a rose, so it's a very thin rose, but you can also see that these parts are actually becoming a little bit flexible. And yeah, I've dropped this many times from even my refrigerator that sits at about 6 foot tall. So it is pretty strong as well, and I also have a big one. Just 1 second, but I guess you guys seen this one in the first video, but this is a way bigger one, and this is a white rose, and you can hear that it's a little bit clicking, but I've also dropped this one from 6 feet, so they're actually pretty indestructible. Not indestructible, if you pull on it they break, but this is a fun thing to print because this can be injection molded, because you can make a mold for it. You can make because every time you wanted to detach it, you would have to make all of these components individually. So that is a really dope thing. And I'm also thinking about just putting a little LED light in here, and you can already put them on a website and sell them. And if you put like somebody's name in it, all of these things are available to do. So let's say you want like a good Valentine present for your significant other, you can get them like a rose with their name in it, 3D printed for a nice price. So that is just the type of thing that I'm thinking about when it comes to these 3D printers. But to get back to, oh no, just one more thing, just 2 more things. This is a baby Lamborghini Aventador, and this has also been a pretty big part of my learning curve because I didn't really know how the settings would work for the infill. And unfortunately I'm wearing a black shirt with a black car, and it's not really contrasting right. Okay, so maybe it's now a little bit clearer if you can see it against my shirt a little bit better. So this is a 3D printed Lamborghini Aventador, but the mistake that I made with this 3D print is that I actually I put the infill on, I believe 20% or 15 or something. So that means that 20% of the inside of this thing is actually solid. And I could have done with way less than that. I could have probably put it at like 2% or 1% or maybe like 5 or whatever, and then it would be way lighter and it would take way less time to print, because this print lasted for about 24 hours. So it's a good thing to know that my printer has the endurance to kind of go through that. But this is a waste of material, this is a waste of time, this is a waste of energy. So this is also a part of the learning curve, because now if I want to sell this thing and do it successfully, I would have to ask like, I don't know, maybe 150 euros or something like this. But you know, otherwise it would have been way cheaper to do it also for me. So unfortunately the side mirrors immediately came off, and I broke the support material off of it. And I also have a box full of that support material right here actually. And you see I actually went to sit on the rose and it actually survived, so that is another sign of how good these things are. But this whole box is basically support material and field print. So the only real field print that I had thus far was this one right here. And the only reason why it filled this, we can also see that it has the same type of curvature, and it just separated from the bed and it dropped off of the printer, and when I came home from work it was laying on the floor instead of on the print bed being printed on. So that is also one of the field prints. But this is the only thing. But I'm saving all of this support material and things that it's printing because there are machines out there that can actually convert all of this back to reusable print plastic again, and that will spool it up again on one of these spools for the 3D print plastic. So because of that, you can save like a little bit of money when you're just saving up all these materials that you don't use anymore. So yeah, that is what this box is for. And then the last and final thing that I'm going through with this 3D printer is that for assemblies like this, you kind of need to figure out what the margins are between components to make sure that they can interact with each other, you know, to make them usable products out of them. So for instance, this whole car is now being printed at 50% scale, but these major components, the bigger components, so the wishbones and the uprights, are at 50% scale, but most of the other components that are actually in here or need to be printed on top of certain things are at a different scale. So these suspension mounts are at 51% scale, while this is at 50%, as I said. So this is a little bit bigger to make sure that it can go on the outside and be mounted pretty tightly without causing a lot of friction. So now this will be able to be in the car without the screw coming loose because it is tightened pretty tightly, but it still doesn't give a lot of friction. And here on the inside, there are these sockets that the ball bearing is actually sitting in, and those are printed at 49.5%, so make sure that they can actually go in this hole right here. So, and these ball bearings look like this, that are actually in here. So there are two circles, half circles, one has a hole in them, so that the actual ball bearings can sit in this socket. So this is the socket for it, and one of them is solid on the bottom, and has just like a hole in it, and it doesn't have a hole in it. This one has a hole in it, so that the ball bearing can actually come out here. So that sits within this circle, and these are printed at 49.5%. and this thing is printed at 50%. So that is something to take into consideration. And the ball bearing itself that actually sits in the socket is printed at 48%. So all of those components I've been printing multiple versions of them at different scales to see which one would fit and what the differential in percentage should be to actually make these parts work together. So that has been a big part of what I've been doing over the last week. So just printing a whole lot, trying to find out all the kinks and all the problems that could potentially arise with this 3D printer. And thus far I haven't really found a lot, to be very honest with you. But I don't know, the devil is in the details, so I'll probably still find some. But as of right now, I hope you guys can imagine what the feeling is for me to have the things that I've actually designed on the computer, to be able to hold them in my hand and to see that the principles that I've used to make this happen, that these principles actually do work, because you know, this is a suspension setup, this would work. So that is very satisfying for me to see that all of the things that I've been learning actually haven't been for nothing. And yeah, it just makes me happy to have this in my hand and to just be able to look at these different components from all of these angles and to see them in the real, in the flesh. And yeah, that is just, it's just, as a designer, it's a big step for me, just personally, on some yeah, just on a personal level. That it's a big step for me. That is basically all I can say. But